Okay, here is Speedrun for the Excel Esports case, the numbers game. I'm going to use some of these custom lambdas and VBA. You can download the link for that download that from the link in the description. So for this level, I've got to sum up everything sum up all the numbers, but not the letters, right? But that's the sum function doesn't sum up letters anyway. So I've already kind of got what I need here, right? So I just look up, even though I can't see it because of the cross hatching, I can just look up, this returning on here. That's level 1. Level 2, again, I just need a sum like this, which I can just bring over to here. And then we look up on here, returning on this one. For this one, I need to convert to hexadecimal, so I'm going to convert from hex to regular decimal, base 10. So I'm going to call this M2 for maze 2, do a little clear contents already, resize, so which unhides everything. So I've got room. And now I just need this built-in hex to des on here. And that is that. And I need X to call all of this, right? Which just gives me the addresses and the values. I'm gonna give these serial numbers also. So just a sequence of 5,000 because it's 50. It's 50 times 100 is 5,000. So now I've got all kinds of good stuff I can use. Need a 3x3 rectangle centered around there. So I can use neighbors list is a user defined function I have for that. And then I can just, look them up on this lookup table I just made. That way we don't have to use indirect, which will slow us down because of it being volatile. And then this is just the sum of these is the rectangle centered around that one. All right, now it's time to play games. So we're going to use, these are the values here, right? So I'm going to call this all values is a named range for that. And the starting index, right? So where do we start playing this game? I can look by doing this because it's just going in normal Excel column row major order is how Excel loves to do things. So we're going to look up that on the in. And now I need to know what indexes to use, right? So this, instead of using the built-in sequence, I will use my X sequence. Starting at that number, stopping at that plus 20. 20 should be plenty for this, right? So that's the index. It's the value, the total, and I need to know if we're done or not, right? So I look up the index on here, returning, oh, no, I'm not gonna do that. That's why I made an index and a named range, right? So on all values to that index there, this will be even faster than that, right? So total, right? Total starts out as 0, and then it's just this plus this. And then I'm done if the next one is greater than 9, then I'm done, because the instructions say to not include the one that makes you stop, right? So now I look up 1 on done, returning on the total. All right, hopefully that is level 4 correct, which it is. For level 5, I'm going to take an entire row. instead of going by index, right? But I need it to decimal already. So why don't I make a little row to look up here, right? So I'm going to just put the row numbers here, and I'm going to use that to look up the array we're going to be playing on, right? So I look up the row number on here, returning on this whole thing. That's going to give me that, and I'll, X to call on this, but I don't need the addresses this time. I just want the numbers. So the is the, the game array. So we're going to play our game on this array. The index starts at 1, but we've got skips, right? Like I can't just go through this whole array because I got to play a skip game, right? So in order to be ready to skip, I'm going to keep track of my index. I'm going to keep track of the index. I'm going to find the value. I'm going to keep track of the total, and I'm going to check if we're done, is what I have to do, right? So first of all, the index is simply on here, right? This. So this index with this being locked, right? On there. And then the total. There's complicated rules for the total now this time, right? It still starts at 0. But I got to do, evens get added at least once, maybe twice, odds get subtracted, but it can never go lower than 0. So it's a max of 0 and some stuff. Previous value plus if is even this. So if this is even, then we're going to add I31. Otherwise, we're not going to add anything. No, we're going to add H32 is the value, right? Not the prior one. Then we're also going to add something else. If it is odd, then we're going to add negative the value, right? Because we subtract the value. And then finally, if and is even and H32 is greater than 9, right? Meaning that's one of those letters, then we add H32 again, right? Because it gets doubled, right? Close out the maximum there, and that should be it. And we are done if the index of the next one, if you try to look up the index and it gives an error, then that means we've run out of numbers and we're done with the row. So is NA or is error, let's say. So is error the next value, then we're done. Otherwise, we're not done. All right. So this is going to copy there. That's interesting that it is. Yeah, no, just because I don't have an index. And then the index, so if this is non-zero, then I increment the index by 1. Otherwise, I add 6 to the index because we skip the next 5 numbers and we still go forward. So that's a gain of 6 total. And I need this to go down. That's the farthest it could possibly go. And now, right, I mean, I can check against the example, right? So it's, it's 24, 48, 37, and ends at 2, right? So it matches the example. So X lookup 1 on the done, returning on the total. And hopefully that is a level 5, a tricky level 5, but there it is. It didn't fool us. Now we're going to do level 6, which makes it a 2-player game. Should not be a problem since we solved the last one. The 1 player, what happens to player 1 is exactly the same as before. So all we got to do is worry about player 2. So player 2 is going to play from the same array, except it's going to start in this column and it's going to get reversed, right? So my X2 call can reverse. I'm not going to clean it. I am going to keep it in row major order, and I'm going to reverse it. So now it's reversed. These index rules are the same. The game array is here for player 2. And the total, like the evens and odds have switched, right? Like if you read all these instructions, odds are evens, odds and evens are switched. So what used to be is even is now is odd and vice versa. But other than that, the logic is the same. And it cannot go under 0. I feel like there's something. The value is 0, then it goes up by 6. This game array is based on this. Is it supposed to be like this? Something is not the way I want it here. Game array 291111. Index is going up. Oh, that's not good. Yeah, it's looking up from the wrong array. All right, so I don't know what I did there. All right, I didn't copy this down. So that's got to get copied down, but it's got to get locked also. Now it's going to be based on the correct array. All right. Yeah, that's looking much more correct. All right, so now XLOOKUP 1 on the done, returning on the total. That's player 1's total. That's player 2's total. So the winner's score is whichever is better of these. And now moment of truth for level 6 is correct. All right, level 7, it's basically like a maze, right? Like it's got to walk through all these letters and it can't walk through the numbers. So we're going to treat it just like a maze. It's even called a maze. All right, so we're going to need a new sheet that I'm going to call cell cost, because I've got this, my route cost lambda uses a Dijkstra-like algorithm to determine the shortest path and it'll also tell us whether cells are reachable or not, which is what we care about in this case. All right, so if this is greater than 9, then it costs 1 to go through. Otherwise, it costs X to go through, meaning that it's impassable, right? So this maze now, right, you just got to go on these 1s and you're in the maze. If you go on the X's, you broke the rules. All right, so now route cost of the cell cost array here, right? And let's see where this is going to be starting at E3, right? So now you can see these have numeric costs, which means they're passable. The X's are impassable. So if that is not equal to X, that means that it is passable. So these trues are the ones that I care about. I'm going to, make a to call here. And I've already got all the values from before, right? So filter all values with that, and that gives me the values that are reachable, and I sum them up to get the answers to level 7. It takes a minute to do some, it's doing Dijkstra's algorithm all these different times, but it worked. So that's all that we need. 1,500 so far. Bonus time. How many numbers are stored as letters? Well, I mean, let's just count if this here is greater than 9. If it's greater than 9, it's a letter. Sum of all the numbers when converted to decimal format, that's just the sum of all values, right? The sum of the ones that are larger than 9 only, right? So, what if I filter all values for all values greater than 9, right? And then sum all that up. And it says it's got to be hex, right? So hex, this is what? The way? Des to hex. All right. How many points can you get in level 4 if you can start wherever you want? Well, let's see. We're going to use the what if table for that. So this is now bonus 4. And instead of going through each game, we're going to go through each possible address here. Keep in mind, you cannot start on the last address. That will not work. But so all the other addresses we're going to test here in a lookup table. We'll keep it here since this is where it's looking up, right? So start with C3. Just need a little bit extra because this assumes that the cell is 9 or less. So sometimes they're not. So if that's true, we can't use it. So if the starting value is greater than 9, then 0. Otherwise, the total here, right? So now if I make this a lookup table based on the address here, takes a second, but hopefully this will give us a good answer here. Let's see. All right, 85. Boom. How many separate regions are there? All right, this is a tricky one. All right, so B5. So let us start with all of the passable cells, right, are the ones that I care about. So I'm going to start by, I'm going to paste this in. I'm going to sort here by, let's not do it that way. I'm going to do equals X to call of this data here, right? This is the data that I really need, are the X's and the ones, right? So now let's filter this where this is equal to 1, right? So now I've got only the passable addresses, and I'm gonna paste values there and start with this, right? So this is all the regions, right? So now what I'm going to do is I'm going to take one of these and make the region, right? So let's say I take the region starting at E3. And now I need to do route cost of did I call the cell cost map something? Should probably do that, right? Call this the cost map. Right, so back on B5, right? So equals the route cost of the cost map with the starting reference being this. So there is those, and I want the addresses, right? So this is not equal to X, first of all, right? That's going to make it, I don't like that. It's not. That's going to make it a mask, right? I've got the trues where I need them. And I do to call on that, right? So now I've got a mask that I could apply to the addresses. Did I call the addresses anything? Call this, addresses. So those are the addresses in the same positions, right? So now what I can do is filter on the addresses based on this mask here. So this is the region that starts at E3. Okay. So now let's say I eliminate those, and what's going to be left? All right. So now I've got to do another filter. Let's make it an X match, right? So I'm going to X match, this. I got to keep these as arrays because otherwise I'm going to be in big trouble. So let me, this is the going to be the pasted values version.
5 minutes over the time.
This is going to be the array version. So I can just use everything as arrays because it's going to get shorter as I go. So I want to make sure these are all arrays. All right, so the ones that are left is going to be based on an X match of this array X matching on this array. All right, so now, see, it found the E3, it found there's C4 in this position, D4 in this position. So now if I filter the big list, right, based on is NA of this mass that I just made, that will give me everything that's not here. So I took this big list and I eliminated these, right? So E3 you can see is gone now, right? C4, right, which used to be here is now gone. There's no C4 anymore, right? So I eliminated these. These are the ones left that might possibly be in a region, right? So now I just take the first one of these and I figure out what's in this region, right? And then I calculate what's left after that. So now I've got all of these regions here and what is left after they're done. So I can make some of these here. And just to see if I'm on the right track or not, I'm gonna ask myself how many rows are in this array, right? So this should be kind of slowly going down as we go, right? So 1856, 1855, 54, 1660. We lost a lot in that region, right? So this is headed steadily down, which is what we want. All right, so now I'm gonna make this, make this about this size, put it all on the left as I like to do. And this should, yeah, let's end it like this so it's an even match. Now I can just start, copying these. Every time I do this, I'm going to double it, right? So copy down to 1569. It's going to take a second to calculate. See how far down I'm going to go. I'm going to let this calculate and see how close I'm getting. All right. No, it's still catching up with me now. Okay, I'm down to 914 left. So that is about halfway there, right? From 1869. So if I double it now, all right, and see, I got a nice calculation clock here. Oh no, all, I can't copy the all though. That's bad. I got to copy only the ones that are left. All right, so only the ones that are left. Otherwise, I reset it, which I don't want. All right, hope I'm getting close now. Let's see. 912. Yeah, now I'm getting close now. There's only 79 left, right? That have not been matched. All right, this should calculate. It's not calculated yet, but I'm going to give it, I'll bet it's going to require a little bit more, a little few more than that. All right, now I'm going to let it catch up and we'll see if it's done or not. All right, yep, there we go. Here's the last one. ASAT is here, and then once we remove that, that's it. It's done. All right, so now I see how many columns I have. I have 258 columns, right? And every region has 2 of these. So 258 columns, right? Let me double check one more time. I'll go out to here. Yeah, 258C. It appeared real fast, right? So equals 258 divided by 2. Boom. 25 minutes, 11 seconds. Thank you for watching.